The night sky has always been humanity's oldest map, scratched into bone and stone, inked on papyrus. Traced in the desert sand, lines of light were drawn into constellations, guides for hunters, sailors, and dreamers. The stars seemed eternal, suspended lanterns of order in an infinite vault. To chart them was to believe the universe itself could be known, measured, reached, but modern science has revealed a truth far more haunting. The sky we see is not the sky that is. Every star, every galaxy, every faint shimmer on the horizon is a message sent long ago, its sender already changed or gone. The further we look, the further back in time we fall. What we map is memory, not presence. And beyond memory lies silence. The universe expands, not gently but relentlessly, pulling galaxies apart, carrying them beyond horizons from which no light will ever return. Already, most of the cosmos has slipped beyond reach. What remains visible is a vanishing fragment, a dwindling archive of light against an ocean of darkness. This is the last map we can draw, not of infinity, but of what can ever be seen. The unreachable sky is real, and it is growing. What does it mean to live at the edge of knowability? To hold in our hands the fading outlines of a universe that hides itself as we chart it. The story begins here with the final cartography of the cosmos and the knowledge that most of reality will forever remain beyond us. For as long as eyes could lift toward the heavens, the sky was both mystery and guide. Ancient civilizations carved their existence into its patterns. To the Babylonians, the stars were omens written in fire, marking seasons and destinies. The Egyptians aligned pyramids with Sirius, the herald of the Nile flood. The Chinese recorded comets and novae, celestial visitors etched meticulously on silk scrolls. The Greeks traced myths into constellations, immortalizing heroes in arcs of starlight. For every culture, the night sky was not only a canvas of beauty, but a map, a guide to time, harvest, and fate. Yet these early maps were bound by imagination. The heavens seemed fixed, eternal, and finite, arranged upon crystalline spheres, as Ptolemy described in the Almagest. His cosmos was an intricate mechanism, Earth at its center, stars embedded like jewels on the outermost dome. For centuries, this ordered universe was unquestioned, the unreachable sky locked into perfect motion. The first fracture came with a quiet revolution. In the 16th century, Nicolaus Copernicus dared to suggest that Earth was not the center but one planet among many circling the sun. His heliocentric model redrew the sky, dethroning Earth and humbling human perspective. Galileo's telescope turned toward Jupiter, revealed moons orbiting another world, and phases of Venus that no Ptolemaic scheme could contain. The Milky Way, once a diffuse band of mystery, was unveiled as countless stars. The unreachable sky grew vaster. Isaac Newton added gravity to the map, a universal tether binding apples to Earth and planets to the sun. Space was no longer a static vault, but a stage of forces, absolute and infinite. The unreachable sky could be explained through mathematics, a clockwork cosmos extending without end. For centuries, this Newtonian vision held sway, comforting in its precision, even as telescopes revealed spirals and nebulae whose nature remained uncertain. Were they clouds within the Milky Way or entire universes beyond? The 20th century shattered certainty. In 1924, Edwin Hubble, peering through the 100-inch Hooker telescope at Mount Wilson, discovered Clifford variable stars in the Andromeda Nebula. Their brightness revealed a staggering truth. Andromeda was not a cloud, but a galaxy, an island universe, far beyond our own. Soon the heavens filled with galaxies, millions upon millions, each a vast system of stars. The map of the sky had grown immeasurably larger, but Hubble's deeper revelation came from measuring their light. Most galaxies showed redshift-stretched wavelengths, signatures of recession. The farther they were, the faster they fled. The universe was not static, but expanding. Space itself was stretching, carrying galaxies apart. The unreachable sky had acquired motion, its horizon receding to measure distance in this vastness. Astronomers built the cosmic distance ladder. Parallax gave the first rungs, measuring nearby stars by the tiny shift of their positions as Earth orbited the Sun. Kiphides, with their pulsating brightness, extended reach to other galaxies. Supernova, exploding stars of uniform brilliance, became beacons across billions of light years. Each rung climbed higher into the unreachable sky, constructing a map whose scale dwarfed imagination, and then came a whisper from the birth of time itself. In 1965, Arno Penzias and Robert Wilson, working with a radio antenna in New Jersey, stumbled upon a persistent background noise. It was no earthly interference, but the faint afterglow of the Big Bang, the cosmic microwave background. The universe itself glowed with memory, a perfect black body spectrum stretched by expansion to microwave wavelengths. This radiation was not from stars or galaxies, but from the universe's earliest moment of transparency. When matter and light first parted ways, 380,000 years after the beginning, the sky was not just a map of stars, but of time itself. With this discovery, cosmology transformed. The unreachable sky could now be measured not only in space, but in age. The universe had a beginning 13.8 billion years ago, and a horizon, beyond which no light had yet arrived. For the first time, humanity could speak of the observable universe, a sphere of visibility bounded by time itself. What lay beyond remained unseen, unreachable. Technology became cartography. Telescopes on Earth and satellites in orbit mapped galaxies in unprecedented numbers. The Sloan Digital Sky Survey revealed a cosmic web, filaments of galaxies stretching like frozen rivers across billions of light years, with immense voids between. The unreachable sky was no longer random. It had structure, rhythm, geometry, yet even as the maps expanded, they revealed absence, gaps where galaxies should be, motions, unexplained by visible matter. Invisible scaffolding was at work. Dark matter, an unseen mass outweighing the luminous universe 5-1. Though undetectable by light, its gravity shaped the cosmic web. The unreachable sky was not only filled with stars, but haunted by the invisible dot, and further still. The discovery of the cosmic microwave background gave cosmologists a tool of exquisite precision. Satellites like COBE, WMAP, and Planck measured tiny fluctuations in temperature across the sky, patterns only 1 part in 100,000. These ripples were the seeds of galaxies. Quantum fluctuations stretched by inflation into vast structures. The map of the unreachable sky now stretched to the dawn of time, carrying the faint imprint of the first instant of creation at each stage. The act of mapping was also an act of erasure. What humanity drew into charts and surveys was already gone, transformed by cosmic time. The stars observed tonight may no longer burn. The galaxies mapped at billions of light years are long changed, their light a fossil from eons past. The unreachable sky was revealed not only in space but in time, an archive that can never be revisited. Yet this impermanence brought not despair but awe. For the first time in history, humanity could claim to hold the universe in its instruments, the positions of millions of galaxies, the whisper of the cosmic background, the very age of creation. The unreachable sky, once myth and imagination, had become a charted reality, but this triumph carried an unspoken tension. The more clearly the universe was mapped, the more it revealed boundaries, horizons beyond which light could never come, forces unseen that dictated its fate, galaxies forever slipping away into silence. The maps were growing, but they also carried the haunting truth: most of the sky would never be ours to reach. The first maps of the unreachable sky were drawn, and with them came the realization that mapping was not mastery, but a final glimpse at a universe already vanishing from view. The universe had revealed itself as vast, structured, and ancient. Humanity had drawn its first grand maps, stretching from the Milky Way to the faint afterglow of creation itself. For a moment, it seemed as though the cosmos might be knowable, its mysteries falling into place like stars in a constellation. But then came the realization that would strike with the weight of revelation: the universe was not infinite in reach. It was bounded, not by walls of matter, but by time and expansion. The sky itself was unreachable. Edwin Hubble's law was the first tremor. By measuring the redshift of galaxies, Hubble found that they were not merely scattered in space, but fleeing, their velocities proportional to their distance. The farther away a galaxy, the faster it receded. This single discovery overturned centuries of assumption. The universe was not static, it was swelling. Space itself was stretching, dragging galaxies apart. The shock was not only scientific, but existential. For millennia, the heavens had been thought eternal, fixed beyond human turmoil. Now they were revealed to be fleeting, dynamic, impermanent. The stars overhead were not eternal lanterns, but brief beacons in a universe that itself had a beginning. The Big Bang Theory emerged as the great explanation. All matter, all energy, all space, and even time itself, expanding from a singular origin. For the first time, humanity faced a cosmos with an age 13.8 billion years and a horizon. Light travels at a finite speed. No matter how powerful the telescope, no observer could see beyond the distance that light had had time to cross since the beginning. The cosmic horizon was not a metaphor, but a physical limit. Beyond it, galaxies exist, but their light will never reach us. This boundary was unsettling enough, but more revelations would follow. In the late 20th century, astronomers studying distant supernova made a discovery so profound it seemed to defy common sense. Instead of slowing under gravity's pull, the expansion of the universe was accelerating. Some unseen force, dark energy, was pushing galaxies apart faster and faster. The cosmic horizon was not simply fixed in place, it was moving. Each passing epoch carried more galaxies beyond visibility, erasing them from the cosmic map. The numbers were terrifying in their implication. Already, most galaxies were unreachable in practice. Even traveling at the speed of light, no future journey could ever reach them. They were receding faster than any spacecraft could chase. The universe was not merely vast, it was actively denying access to itself. This was the first great scientific shock of modern cosmology, that most of the universe is not only unseen, but fundamentally unreachable. What we observe is a vanishing fraction, a temporary view offered at a privileged moment in cosmic time. The night sky is not a stable canvas, but a dissolving one. Every observation is a farewell. The philosophical weight of this truth presses deeply. To map the universe is to admit that the map is incomplete, not by lack of effort, but by the very structure of reality. The finite speed of light and the acceleration of expansion conspire to veil most of existence forever. The unreachable sky is not an illusion but a fact of physics. The scientific community struggled with this dissonance. On one hand, the equations of general relativity explained the expansion elegantly, predicting the very horizons that now haunted cosmology. On the other, the discovery of dark energy raised questions with no precedent. What is this force that inhabits the vacuum, pushing galaxies apart? Why is its strength so small, yet so perfectly balanced to dominate the universe only now? The cosmological constant problem became infamous. Quantum theory predicts a vacuum energy 120 orders of magnitude larger than observed. No discrepancy in science has ever been so extreme. The frozen storm of dark energy, as faint as it appears, should, by all rights, have torn the universe apart instantly after the Big Bang, and yet it has not. The unreachable sky is both impossibly fragile and inexplicably stable. The emotional resonance of these discoveries is profound. Humanity had once believed the stars eternal. Then it learned the stars themselves lived finite lives, born, burning, and dying. Now it was forced to confront the mortality of the sky itself. The galaxies visible tonight will fade from sight. The constellations that guided civilizations will dissolve not through human neglect, but through cosmic decree. In the far future, billions of years from now, the sky will be stripped bare. Only the nearest galaxies, perhaps only the merged remnant of the Milky Way and Andromeda, will remain. All else will have crossed the cosmic event horizon, never to be seen again. To future astronomers, the universe will appear small and empty, its true vastness forever lost. The maps drawn in this epoch will be the last that encompass the cosmos as it truly is. This realization is not simply shocking, it is disorienting. Science had always expanded the horizon, pushing further with each invention, each telescope, each equation. But here, the frontier closes not from lack of ingenuity, but from the very laws of physics. The unreachable sky cannot be conquered, cannot be crossed. It is a reminder that knowledge has limits inscribed in nature itself. The human mind, accustomed to imagining infinity, struggles with these horizons. What does it mean that most of reality is beyond reach? Are we condemned to ignorance or blessed to witness the cosmos at its most revealing moment? The paradox is stark. We live in a privileged epoch, able to see a universe still full of galaxies, still echoing with the light of its beginning. Future beings may never know this truth. This privilege is unsettling. Why now? Why do conscious minds arise at the precise moment when the universe is visible in its full expanse, but before dark energy carries it away? Cosmologists call it the cosmic coincidence problem. It feels as though we have arrived at the theater, just as the curtain begins to fall, able to glimpse the play only in its fleeting final act. The scientific shock is therefore double. The universe has yielded its secrets generously, allowing humanity to chart stars, galaxies, and the afterglow of creation. Yet at the same time, it has revealed its refusal to be fully known. The unreachable sky is not a metaphor for ignorance, but a law of existence. In the silence of the night sky, one hears the paradox. The more we know, the more we realize how little can ever be known. The maps expand, but the horizons retreat. The sky is a vanishing gift, offering its truths only once, only now, only to those who dare to look. Once the shock had settled that the universe was not eternal, not infinite in reach, but bounded by horizons, science turned to the task it knows best, measurement, to confront the unreachable sky. Astronomers did not despair. They built instruments, sharpened their mathematics, and began to probe the limits of what could be known. If the universe was slipping away, then each moment of visibility became precious. The deeper the investigation, the more urgent the pursuit. The first great tool was light itself, stretched and red-shifted across the void. With it, astronomers constructed the cosmic distance ladder. Parallax revealed the nearest stars. Measured as Earth circled the sun, Cepheid variables, pulsating stars, whose brightness waxed and waned with predictable rhythm, became standard candles, extending sight to distant galaxies. Supernova, detonations of dying stars, burned even brighter, serving as lighthouses to the farthest reaches. Each rung of this ladder built a larger map. Each observation expanded the chart of the unreachable sky. But mapping galaxies was only the beginning. In the 1980s and 1990s, vast redshift surveys traced the positions of hundreds of thousands of galaxies. What emerged was startling. The universe is not random, but woven into a cosmic web. Galaxies cluster into filaments and walls, leaving behind great voids, like bubbles in an unseen foam. The Sloan Digital Sky Survey expanded this vision, producing three-dimensional maps of the cosmos on scales unimaginable. The sky revealed itself a structure not uniform but sculpted. These patterns were not accidents. They were fossils. Each filament, each void, each cluster of galaxies carried the imprint of the universe's earliest moments. Scientists traced them back to a deeper origin, the cosmic microwave background. In 1965, Arno Penzias and Robert Wilson discovered a faint hiss in their radio antenna, a relic of the Big Bang itself. Later missions, COBE, WMAP, and most recently Planck, turned this discovery into a map of the infant cosmos. Tiny temperature fluctuations in the microwave background revealed the seeds of galaxies laid down when the universe was less than 400,000 years old. This was no ordinary map. It was the earliest chart possible, a portrait of the cosmos when it was still a storm of plasma. The ripples in this afterglow were sound waves, baryon acoustic oscillations, frozen into the fabric of space. Billions of years later, these primordial waves determined how galaxies would cluster, how voids would open, how the sky itself would be structured. To study these oscillations is to hear the echoes of creation still ringing through the unreachable sky, yet investigation did not end with what can be seen. Gravity itself became a tool, bending light into new maps. Einstein's theory predicted that mass distorts space-time, curving the path of light. Astronomers confirmed this through gravitational lensing, distant galaxies distorted into arcs and smears by intervening mass. Through this subtle bending, they traced what eyes could not see, the scaffolding of dark matter. Though invisible, dark matter reveals itself in these distortions, shaping the skeleton of the cosmic web. The unreachable sky is thus mapped, not only in stars, but in shadows. At the same time, particle physics joined cosmology. The behavior of neutrinos, ghost-like particles passing through planets and stars without interaction, became another probe of the unreachable. Their sheer abundance made them a cosmic fluid, influencing how galaxies formed. Underground detectors such as Super Kamiokande in Japan and IceCube in Antarctica sought these faint messengers, catching flashes of light from their rare interactions. Each neutrino recorded was another data point in the hidden architecture of the universe. The deeper the investigation, the more paradoxes emerged. Observations of the cosmic microwave background showed the universe to be flat, balanced between collapse and runaway expansion. Yet this balance was too perfect, raising the flatness problem. Why is the universe so finely tuned? The horizon problem followed. Regions of the early universe, separated by vast distances, seemed to share identical properties, as if they had once been in contact, though light could never have crossed between them. The solutions pointed to new theories. Inflation, a sudden burst of expansion in the first fraction of a second, could stretch the cosmos smooth and flat, explaining its eerie balance. Quantum fluctuations during inflation could seed the very ripples seen in the microwave background. Thus, the unreachable sky carried the fingerprints of phenomena occurring at energies far beyond any collider, in timescales far shorter than any experiment could reach. Yet even with these answers, mysteries deepened. If inflation occurred, it may not have stopped everywhere. Some regions of space might still be inflating, birthing new universes beyond our horizon. The unreachable sky was no longer just distant. It was perhaps infinite, spawning realms, forever hidden from ours. The maps humanity drew were not incomplete by chance, but by necessity. Beyond the boundary may lie an endless multiverse, unreachable by definition. Still, cosmology pressed forward. With new telescopes, astronomers pushed further back in time, discovering galaxies forming less than 500 million years after the Big Bang. James Webb Space Telescope extended this frontier, capturing galaxies so faint and redshifted they test the very limits of models. Each one is a message from the unreachable. Its light stretched thin across billions of years to reach us now. But the most sobering realization was this: every map of the universe is a map of the past. The light from galaxies, billions of light years away, shows them as they were billions of years ago. The deeper the look, the further back in time. No telescope, no matter how powerful, can show the universe as it is today. The unreachable sky is not only distant, it is irretrievably gone. We see ghosts, not reality. We chart echoes, not the present. And so the investigation became layered. Maps of galaxies, maps of dark matter, maps of ancient sound waves, maps of faint afterglows, maps of elusive particles. Each one fills in part of the unreachable sky. Yet the more precise the charts, the more poignant the truth. What is drawn is not the universe as it is, but as it was. The cosmos has already moved on. The weight of this realization lingers. Every telescope is a time machine. Every image is a window into what no longer exists. The unreachable sky is unreachable not only because of distance and expansion, but because time itself refuses to let us cross. Still, humanity continues to investigate. Supercomputers simulate universes with billions of particles, testing theories against surveys. Observatories measure the faintest fluctuations in ancient light, searching for signatures of inflation. Gravitational waves are detected from colliding black holes, hinting at a deeper background, stretching back to the Big Bang. Each tool extends the map. Each discovery sharpens the paradox. The deeper we investigate, the clearer the truth becomes. The unreachable sky is not an empty metaphor, but a cosmic decree. It is written into the laws of physics that most of the universe cannot be seen, cannot be touched, cannot even be known as it truly is. The maps we draw are works of devotion, fragile attempts to sketch infinity with finite tools, and yet, perhaps, that is their power. The unreachable sky is a mirror of human existence itself, fleeting, partial, never complete, yet filled with meaning precisely because of its limits. Science does not collapse in despair at this horizon. It sharpens its instruments, draws its maps, and continues, knowing that the cosmos will never yield entirely. In that persistence lies the essence of discovery. The maps were drawn, the instruments refined, the first deep portraits of the cosmos complete. Yet with every contour added to the chart, the mystery did not shrink. It grew. The more precisely the universe was measured, the more clearly its absences appeared. Horizons sharpened like edges of glass. The sky seemed to step backward as understanding advanced. A tide retreating from a shore it had only just revealed. At the center of this deepening paradox stood the notion of the cosmic event horizon, not the horizon of a black hole, but one that embraces the universe itself, a boundary in space-time defined not by walls of matter, but by the speed of light and the acceleration of expansion. There are regions of space whose light can reach observers today, because those photons set out long ago when cosmic distances were smaller. Yet, from this moment forward, the light emitted by those same regions will never arrive. Their future and ours are split by expansion. They are visible, but forever, unreachable. This is the first vertigo, the realization that the map includes places already lost to contact. The universe presents images from which no reply can ever be sent. There is no voyage, no message, no future handshake across that divide. The last shared influence has passed. The sky holds ghostly neighbors who can never again be addressed. From this horizon flows a second vertigo, time weaponized by expansion. As the universe grows older, the horizon contracts in a curious way relative to observers. Galaxies that now hang on the edge of visibility cross the boundary and dim into permanent night. The map, once drawn, begins to erase itself. Each decade of observation is a subtraction as much as a discovery. The cartographer of the cosmos writes with dissolving ink. Project the clock forward, and an unsettling picture emerges. In tens of billions of years, the Milky Way and Andromeda, long since merged into a single star city, will shine in a sky almost empty. The distant web of galaxies will have slipped behind the event horizon. Their ancient light, finally exhausted, will fall silent. Future astronomers, armed with any conceivable telescope, will find a cosmos that appears small, static, and lonely. The grand narrative inferred in this era, expansion, background radiation, the first flash of inflation, will be all but impossible to reconstruct. The evidence will have been carried away by the very law that created it. Thus arises the idea of a privileged moment in cosmic history. The present era, a thin, improbable slice of time, is precisely when the universe is both old enough to reveal its origins and young enough to remain visibly vast. Before now, galaxies had not yet formed in maturity. Later, they will have fled the stage. Conscious minds have appeared while the curtain is still half drawn, when the orchestra of ancient light still plays. This coincidence feels less like chance than a riddle. Why did cognition bloom at the one interval when the unreachable sky is most legible? Is selection at work, life thriving, where the cosmos can be learned, or is this alignment merely a fortunate accident in an indifferent unfolding? Questions ramify outward, toward the edge where physics becomes metaphysics. What lies beyond the horizon? The immediate answer is mundane and monumental at once. More of the same. More galaxies, more voids, more filaments of dark matter receding in their local frames, obeying the same equations that describe the visible. But the deeper answer is stranger. The horizon is not simply far away. It is a limit of relationship. It marks the boundary of what can causally touch an observer. Beyond it may lie not just different places, but different fates. The unreachable is not a curtain. It is a fork in time to read the boundary script. Theorists look back to the first instant, inflation, that burst of exponential growth, in the universe's infancy, can explain the flatness and smoothness of the observable cosmos. Yet inflation itself carries a paradox that intensifies the mystery. In many models, it does not end everywhere. It stops in patches, leaving other regions to continue expanding eternally. Bubbles form, domains like ours drift apart faster than light can mediate, forever disconnected. If such eternal inflation occurs, then the unreachable sky is not merely large, it is fractal and unending. Each horizon encircles a self-contained cosmic chapter, complete in itself, yet one of countless volumes in an ever-growing library. The maps of any one bubble can never include the shelves beyond, within our bubble. The cosmic web, filaments and nodes, voids and walls, appears as a fossil of ancient sound. But as acceleration drives matter apart and star formation declines, this web becomes a frozen relic, a sculpture slowly submerged by darkness. Clusters remain bound. The vast threads between them thin and fade. The web stops speaking to distant listeners because messages can no longer cross. The sculpture remains, but the audience is dispersed. All the while, the arithmetic of horizons tightens its grip on meaning. If signals cannot connect, what becomes of knowledge? Physics rests on inference from observation, yet the unobservable grows. Cosmology must then turn to principle, to the insistence that laws deduced here and now extend universally. It becomes an act of disciplined faith, that curvature measured locally, spectra gathered from the deep past, fluctuations mapped in microwave light, all continue beyond the event horizon's veil. The sky demands trust in pattern beyond proof. The mystery deepens further when information itself becomes the currency. Black hole physics suggests that horizons possess an entropy proportional to their area, and that information is never truly destroyed but encoded at a boundary. This holographic intuition tempts cosmology with an audacious thought. Perhaps the information of the observable universe is likewise describable on its horizon. If so, the last map of the unreachable sky might not be a survey of points in space, but a ledger of bits on a cosmic screen. The map would still be last, not because nothing remains to be known, but because all that can be known is already written on the edge. Against this conceptual backdrop, practical puzzles sharpen to blades. Measurements of the Hubble constant, the current rate of expansion, disagree when taken from the early universe's relic light versus the late universe's standard candles. This tension may be a calibration puzzle. It may be a clue. If it is a clue, then the sky is signaling that the bridge between past and present is missing a beam, that some unseen component or evolution in dark energy has shifted the pace of expansion. The map is accurate. The legend is incomplete. The horizon also recasts time. In general relativity, simultaneity is not universal. Slices of now depend on motion and gravity. Add an event horizon, and now fractures further. Whole swaths of the universe have no shared present with observers here. The unreachable sky is not only elsewhere, it is elsewhere. To contemplate this is to feel the conceptual floor tilt. The last map begins to look less like a flat projection and more like a family of layered transparencies, each an incompatible present, none capable of totality. In the far future, the consequences grow existential. Civilizations that endure will wake beneath empty skies. Their physicists, deprived of the microwave background and the chorus of receding galaxies, may conclude they inhabit a static island surrounded by darkness. Their cosmology would be elegant and wrong. Our archive, the data of this epoch, becomes not simply knowledge, but inheritance. A message in a bottle cast forward to minds who will lack the clues we possess. The last map is not only a record, it is a rescue, yet even as the horizon closes, new channels open. Gravitational waves traverse the cosmos with a different voice, bearing memories of cataclysms and, perhaps, of the first fractions of a second if a primordial background can be revealed. Neutrino and relic gravitational backgrounds might one day be detected, adding senses beyond light. But expansion is impartial. These too have limits. No messenger outruns a horizon expanding fast enough. Thus the escalation resolves into a quiet, unbreakable knot. The universe is both knowable and withholding. It offers a luminous archive, galaxies, background radiation, the aftershocks of inflation, and simultaneously removes the remainder from reach. The cartographer is gifted with a canvas that fades as it is painted. The deeper the pigments of knowledge are laid, the paler the edges become. What then is the last map? It is the composite of everything that can ever enter a telescope, a detector, a mind integrated across all wavelengths, all messengers, all epochs. It is the limit of inference, the horizon of principle, the ledger of information on the boundary. It is the sum of the heavens as they choose to be known, and what lies beyond. The same physics, perhaps, or different constants, different symmetries. Different narratives born of inflation's endless branching. The mystery remains, not as a failure of curiosity, but as the precise shape of reality's generosity. The sky gives enough to ignite understanding and withholds enough to preserve wonder in the end. The escalation of the unreachable sky is not a threat but a vow, that there will always be horizon, always be distance, always be a reason to look. Again, the last map is not a terminus. It is a promise that knowledge and mystery will meet perpetually at an ever-moving edge, and that the act of mapping, undertaken in humility and awe, is itself the most human answer to a universe that recedes even as it reveals. Speculation is where cosmology steps out of the comfort of measurement and leans against the winds of imagination, tethered only by mathematics. When the maps end, theory begins, and it is in this liminal territory that the unreachable sky takes on new, unsettling dimensions. The outlines of galaxies may vanish into the dark, but equations whisper of what may lie beyond. At the core of these whispers stands dark energy, the enigmatic driver of cosmic acceleration. Einstein first introduced a term to hold the universe static, the cosmological constant, later dismissing it as his greatest blunder. Yet the cosmos revealed that this constant, or something like it, is very real. Dark energy today. accounts for nearly 70% of the universe's energy budget. If it is truly constant, then its meaning is profound. It is the energy of empty space, the vacuum itself. The frozen storm that fills every corner of the void is not silent. It pushes galaxies apart. The simplest speculation is also the most unsettling. Emptiness itself has weight, and it commands the destiny of the cosmos. But constancy is not guaranteed. Some theorists propose that dark energy may be dynamic, a field akin to the inflaton that once ignited cosmic inflation. In this view, the acceleration could change with time, its pressure waxing or waning. If it grows stronger, the universe races toward a big rip, a future in which galaxies, stars, planets, and even atoms are torn apart as expansion overwhelms every bond. If it fades, the cosmos may eventually slow, perhaps even collapse back in. A big crunch. Each model writes a different ending to the unreachable sky, each dictated by the true nature of this hidden energy. Layered upon these are speculations of a more precarious kind. Vacuum metastability. Particle physics hints that the Higgs field, which grants mass to matter, may not be settled in its lowest possible state. Instead, it may rest in a false vacuum, a plateau of temporary stability. If so, a fluctuation could one day trigger transition to a lower state, creating a bubble of new physics expanding at near light speed, annihilating the universe we know. There would be no warning, no preparation, only the sudden rewriting of all laws. To contemplate this possibility is to feel the floor beneath existence shift, as though reality itself were contingent on a balance we cannot control. The unreachable sky becomes not a horizon, but a precipice. Some models reach outward instead of inward, invoking the multiverse. If inflation is eternal, then every bubble universe may carry different parameters, different constants of nature, even different dimensionalities. Our observable sky would then be a mere parochial patch in a vast mosaic. The unreachable regions beyond our horizon might not simply be more of the same, but entirely other realities, stitched together only by the inflationary process that spawned them. The cosmic coincidence that we exist just as the universe is still visible could then be explained anthropically. Only in certain bubbles do conditions allow stars, planets, and life. And it is only within those that observers arise to ask why. Such speculations press further into the mathematical fabric of physics. String theory imagines the fundamental constituents of reality not as point particles, but vibrating strings, their modes giving rise to particles and forces. The vacuum, in this scheme, is not singular, but a vast landscape of possible configurations, shaped by curled extra dimensions. Each valley of the landscape corresponds to a different vacuum state, a different universe. Our unreachable sky is then one configuration among perhaps 500 possibilities, an infinitesimal coordinate in an unimaginably broad map. Other approaches rewrite space-time itself. Loop quantum gravity envisions geometry as discrete, woven from quanta of area and volume. If true, the horizon and the unreachable sky may not be continuous expanses, but lattice of finite granularity, stitched by loops of connection. The very fabric of the unreachable could be pixelated, the storm at its heart arising not from infinity, but from a hidden arithmetic of space. Speculations also take form in the language of holography. From black hole thermodynamics comes the startling principle that the information content of a volume is not stored within, but on its surface. If applied to the cosmos, This suggests that the observable universe might itself be a projection, its three-dimensional contents encoded on the two-dimensional horizon. In this light, the unreachable sky is not a limit to reality but the surface where reality is inscribed. The last map may not chart galaxies but the informational density of the boundary that contains them. Yet with speculation comes humility. Perhaps the anomalies and tensions are not gateways to new physics but mirages of measurement. The Hubble constants disagreements may resolve into calibration errors. The strange alignments in cosmic background maps may dissolve under more refined data. The universe may be simpler than it teases. And yet, even if illusions, their persistence suggests something profound about the human gaze. That the very act of looking generates patterns that echo with meaning. To chase these echoes is not folly, but the essence of science, to mistake noise for signal until proven otherwise. And in that vigilance, sometimes to find truth, philosophical questions grow from these frameworks, like shadows cast by the equations. If the unreachable sky is infinite, then what does infinity mean to finite minds? If the vacuum is unstable, then what is permanence but a fragile pause? If the multiverse exists, then is our universe less precious or more one? Star in a sea, or a cathedral uniquely tuned to birth awareness? If holography is correct, then is existence itself an illusion, a projection from surfaces we cannot touch? Speculation offers no answers. It offers possibilities, each more unsettling than the last. But in their convergence, a pattern appears. The unreachable sky may not be unreachable by distance alone. It may be unreachable by principle. Its edges are horizons, its futures sealed in quantum probabilities, its beyond hidden in higher dimensions or alternate domains. To speculate is to accept that reality is larger than measurement, that truth may outrun both telescope and theory. The last map of the unreachable sky, then, may be not a chart of galaxies, but an atlas of ideas. Dark energy, false vacua, strings, loops, holograms. Each is a line drawn toward an edge that cannot be crossed. Each is a reminder that speculation is itself a kind of cartography, charting not the heavens, but the contours of human imagination pressed against the void. And in this speculative cartography lies a paradox as profound as the sky itself, that to imagine beyond the horizon is already to step where observation cannot follow. Theories may prove wrong, but the mystery remains. The unreachable sky endures, not diminished by explanation, but made vaster by the recognition that even our boldest conjectures fall short of its depth. The unreachable sky cannot be touched, yet humanity has never yielded to mystery without pursuit. If most of the cosmos lies forever beyond, then science must find its edges, capture its faint echoes, and record its fading light before it vanishes. Across Earth and orbit, beneath mountains and within deserts, an array of instruments has been raised like altars to the unknown, each designed to probe the silence between galaxies and listen for the whispers of what lies beyond the James Webb. Space Telescope is the newest eye to open upon the unreachable sky, suspended beyond the moon's orbit at the L2 point. Its golden mirrors unfurl to drink in light stretched by billions of years of expansion. Webb peers into the red-shifted dawn of cosmic history, gathering the glow of galaxies born less than a few 100 million years after the Big Bang. Each faint smudge of light is more than an image. It is a message sent from the edge of the observable, a fragment of a map drawn in photons that have crossed nearly the entire history of time. Webb is not only cataloguing stars, but sketching the first outlines of the unreachable. On Earth, another sentinel is rising, the Vera C. Rubin Observatory, with its 8.4-meter mirror and colossal digital camera. Rubin will scan the sky in unprecedented detail, building a moving atlas of billions of galaxies. By tracking their motions, their clustering, and their distortions by unseen gravity, Rubin will expose the fingerprints of dark energy, the agent accelerating expansion. In its nightly sweeps, it will not merely observe stars, but chart how the frozen storm of vacuum energy reshapes the heavens. Its data will become the scaffolding of the last great sky map. Orbiting Earth, future missions will extend this quest. NASA's Nancy Grace Roman Space Telescope, scheduled for launch later this decade, will measure the universe's acceleration with exquisite precision. By studying thousands of distant supernova dying stars that explode with predictable brightness, Roman will reconstruct the cosmic expansion curve. Each point on that curve is a boundary stone on the last map, marking how swiftly the unreachable horizon retreats. Alongside it, the European Space Agency's Euclid mission has already begun surveying galaxies and dark matter filaments, tracing the skeleton of the universe. Together, Roman and Euclid are cartographers of geometry itself, mapping not just matter, but the very curvature of space-time. Yet telescopes are only part of the arsenal. The cosmic microwave background remains the deepest observable screen. The fossil light of the Big Bang, frozen when the universe was 380,000 years old. Missions like COBE, WMAP, and Planck revealed this faint glow in stunning detail, mapping tiny temperature fluctuations that seeded galaxies. But the frontier is not yet closed. Upcoming experiments, such as CMB's 4 and Japan's Light BIRD, will measure the polarization of this ancient radiation, seeking the subtle swirls left by primordial gravitational waves. If detected, they would confirm inflation and expansion so violent that most of the universe became unreachable in its first instant. These signals would be a map not of stars, but of the storm that sculpted the sky before stars even formed. Another channel of observation listens not to light, but to the trembling of space-time itself. In 2015, LIGO detected gravitational waves. From colliding black holes, ripples from cataclysms, billions of light-years away. Since then, Virgo and Cagra have joined, building a global network. Their triumphs lie in hearing events too dark for light to reveal. But future detectors may do more. The planned LISA mission, 3 spacecraft orbiting the Sun in formation, will open a low-frequency window capable of detecting gravitational waves from supermassive black holes, and perhaps even from the early universe. If faint relic waves from inflation still echo in space-time, LISA may catch their signature, a vibration from the unreachable sky itself. While the largest instruments stretch across deserts and orbit in space, the smallest seek answers in controlled chambers, deep underground, shielded from cosmic rays. Experiments like Xenon and LuxZeppelin search for the faintest interactions of dark matter. Should a particle of that hidden substance collide with an atom in their ultra-pure detectors, it would mark a direct link between the unseen cosmic scaffolding and the laboratories of Earth. Each null result redraws the boundaries of theory, refining what the unreachable sky is made of. To capture the unseen requires patience measured in years, but the hope remains that the void itself will leave a fingerprint. Particle physics contributes in parallel. The Large Hadron Collider continues to probe energies where anomalies may reveal hidden forces or unstable fields. Its discovery of the Higgs boson confirmed one element of the frozen storm, but its deeper aim is to test whether the Higgs is stable or balanced on a false vacuum. Upgrades to the collider push further, each collision a question posed to the foundations of existence. If new particles appear, they may be emissaries of the unreachable. Bridging cosmology and quantum theory, supercomputers provide another kind of telescope, simulating universes under different laws. By modeling galaxies, voids, and filaments across billions of light years, these digital skies are compared with surveys from telescopes. When discrepancies appear, they reveal where theory falters and where new physics may wait. Simulations become trial maps of the unreachable, offering visions of universes we cannot see but can approximate through. Mathematics, analog experiments echo this pursuit in miniature. In laboratories, physicists use Bose-Einstein condensates to mimic horizons, reproducing in sound waves the effects of black hole evaporation predicted by Hawking. Others manipulate superconductors and optical lattice to simulate cosmic fields. These tabletop storms mirror the unreachable sky at scales we can manipulate, teaching us that even the vastest mysteries may be rehearsed in microcosm. Together, these tools form a symphony of inquiry. Telescopes catch ancient photons, detectors wait in silence for dark particles, interferometers listen to spacetime's tremors. Colliders unleash primordial energies, computers weave digital universes. None can capture the unreachable sky in its entirety, but each illuminates a fragment. Their data is stitched into provisional maps, each provisional map into a larger mosaic. With every observation, the boundary of ignorance recedes, even as the cosmic horizon pulls away faster, and yet time is against us. As dark energy drives galaxies beyond visibility, the sky grows poorer in messages. The light of the first galaxies fades. The signals of the cosmic microwave background stretch thinner. Future civilizations may see only darkness beyond their own galaxy, the unreachable sky erased. The urgency of these tools lies not only in discovery, but in preservation. We are the first, and perhaps the last, beings who can draw the true map of the universe. To fail is to let the unreachable vanish without record. Science stands now in its most audacious moment, with instruments that span Earth and space, with equations that probe beyond sight. It attempts what no creature has done before, to map the unreachable, to measure what hides beyond all horizons. The tools are sharpened, the listening profound, and still the silence resists, reminding us that the universe does not yield its secrets easily. The map is being drawn, but always at the edge of vanishing ink. The sky has always been a mirror of human longing. For millennia, people lifted their eyes to the stars and believed the heavens eternal, infinite, and within reach, if only one climbed high enough. Yet the revelations of modern science have rewritten that dream. The universe, it seems, is vast beyond imagination, but it is also fleeting, unreachable, a cosmos that hides most of itself behind walls of time and acceleration. We live not beneath an infinite canopy of stars, but beneath a sky that vanishes even as we watch. And so humanity finds itself holding the last map of the unreachable sky, a chart of lights that will soon fade from sight, leaving only memory and silence. There is a paradox at the heart of this realization. The universe is infinite in scope, yet finite in what we can ever know. Our telescopes stretch their gaze across billions of light years, but even their most powerful eyes are bounded by horizons that no signal can cross. Beyond them may lie endless galaxies, whole structures larger than imagination, yet to us they are ghosts, unreachable forever. What is knowledge in such a cosmos? To map the stars we cannot touch is to acknowledge both triumph and defeat. Triumph in tracing the edge of the observable, defeat in realizing the rest is sealed away. This awareness cuts deeper than astronomy. It touches the human condition itself. Lives, like galaxies, are bounded by horizons. Each memory is a fading light. Each future possibility lies beyond reach until time delivers it. Just as we see galaxies not as they are, but as they were, we see ourselves always in reflection, in echoes of choices, in the afterglow of vanished days. The unreachable sky is not only overhead, it is within us, shaping how we understand existence. Philosophers once imagined the void as empty, silent, and dead. Science has shown it to be alive, driven by dark energy, filled with storms of quantum fields. Yet the greatest revelation may not be what lies inside the void, but what it denies us. We live in a universe that withholds most of itself. The unreachable is not an accident. It is built into the fabric of reality. In this light, knowledge becomes a fragile gift, a privilege of living at a unique moment. For billions of years, the sky was unreachable because there were no eyes to see it. In trillions of years, it will be unreachable again, erased by expansion. Only now, in this narrow cosmic window, can it be mapped. We are the first and perhaps the last cartographers of truth. What does this mean for the meaning of science? It suggests that discovery is not conquest, but remembrance. To map the unreachable is to preserve what the future will lose. Every image from Webb, every survey from Rubin, every measurement of cosmic background radiation, all are acts of preservation. Records of a sky that one day will no longer exist. Science is not merely about prediction, it is also about memory, about carrying the echo of the unreachable into the long silence ahead. There is, too, a haunting beauty in this limitation. If everything could be known, perhaps wonder would vanish. It is the unreachable that gives the cosmos its grandeur, the silence between answers that makes each glimpse precious. The unreachable sky reminds us that mystery is not an obstacle to meaning but its foundation. To live in a universe that hides itself is to live in a universe that invites awe. Knowledge ends at the horizon, but imagination does not. Speculation deepens this reflection. If beyond the horizon lie other universes, then the unreachable sky is not merely a map, but a doorway, locked to us forever. If inflation scattered countless bubbles of reality, each with different laws, then our map is not of everything, but of one fragile island in an infinite sea. And if the holographic principle is true, then all we know may be encoded on the horizon itself, a surface of unreachable information painting the interior we inhabit. In every possibility, the unreachable becomes not an absence, but a presence, a reminder that reality is richer than perception. The emotional weight of this truth is profound. Civilizations rise and fall under stars that one day will not be seen. The Milky Way, now a shining river across the night, will in time be all that remains visible. Distant galaxies, once companions in our maps, will recede into invisibility. The universe will contract into solitude, leaving only local light, only local memory. And yet, within this fragility lies meaning. We exist at the moment when the cosmos is still open, when the unreachable is still partly reached, when the last map can still be drawn. It is a privilege written into the era of our existence. Perhaps This is the final lesson of the unreachable sky, that knowledge is temporary, but wonder is eternal. The stars may vanish, the maps may fade, but the act of looking, of asking, of imagining beyond horizons, that remains. To hold the last map is not to despair, but to marvel. It is to understand that even in loss there is beauty. Even in silence there is truth. The closing image is this: humanity standing beneath the night sky, a sky filled with stars that will one day be gone. The map we hold is not of conquest, but of awe, a fragile chart of unreachable infinities. In its lines and coordinates, we see both the vastness of the cosmos and the limits of our perception. The unreachable sky is not failure, it is invitation. An invitation to live with mystery, to honor the fleeting window of light, and to remember that even in the face of vanishing, the universe remains a cathedral of wonder. The last map is not complete. It never can be. But in its incompleteness lies its meaning, a testament to human curiosity, drawn against the silence of eternity. And as the lights recede beyond horizons, what remains is not despair, but reverence for the unreachable sky, and for the fragile beings who dared to chart it.